Hi, greetings. I'm Alex Lingle from Intel, and in this video, I will show you some really cool things you could do with AI applications. Today, we will be using an open source deepfake tool for generating AI avatars you can use in video conference calls. Some of the key takeaways from today's video will help developers understand how to take advantage of the AI accelerator features available across Intel-based platforms today. Now, you will also learn how to sign up for Intel's DevCloud for oneAPI projects, run remote workers in the Intel DevCloud to perform the AI inference, and then also join a video call using OBS to show off that virtual AI avatar rendering in real time. The open source code used for our demo today is actually from an open source Git community project called avatarify from Ali Aliyev based on the first order model. A common notion in the developer community today is that you need to have a powerful GPU to run the AI workload. What I'm going to show you is how this is no longer the case when you're optimizing your applications for Intel and oneAPI. So let's start first with what is oneAPI? So oneAPI is actually a unified cross-industry initiative for an open standards-based cross-architecture programming model. What that also means is it's basically a collection of programming interfaces and APIs that are optimized on the Intel platforms. This eliminates the need for developers to maintain separate code bases, tools, and having to maintain multiple languages. In turn, that allows for high performance and efficiency across all the XPU accelerators in the ecosystem. So when users do get access and sign up for the Intel DevCloud, they'll immediately have access to a server rack composed of various CPU, GPU, and FPGAs that they can use for sandboxing their application. And in addition with oneAPI, this means that developers can take advantage of the available XPUs in the system hardware to parallelize and make use of the multiple architecture accelerators optimized for executing the application. This means that you can write your code once, ensure that it will run optimized on any Intel platform architecture, including CPU, Xeon, FPGA, iGPU, integrated graphics, VPUs, and just XPU as a whole. But before we get into it, I want to make sure everybody understands what a deepfake really is. So let's make sure we understand the term. Now you may think, but isn't a deepfake a bad thing? So every time we read about deepfakes in the press, it's often associated with something nefarious or negative. But just like with any new tools and new technologies, as they come, into maturity, they can often be used for good or bad, depending on the actor that's holding that tool. Now, in fact, some companies are now using deepfakes as a corporate training tool. And even for entertainment purposes, the film industry has even been using deepfake techniques to create music video content, using AI for good to protect the victims of anti-LGBTQ persecution, with an upcoming HBO documentary called Welcome to Chechnya. Now, let's show you how to sign up for access to the Intel DevCloud for oneAPI projects. All right, so this is the website registration sign up for getting access to the Intel DevCloud for oneAPI projects. Here you're going to fill out your information. And once you hit submit, shortly after, you're going to get a list of instructions on how to log in with your set of credentials. Right here, I've already got my login information. So I'm going to go ahead and log into our notebook. And so it's just going to fire up the Jupyter notebook. And now we have it running. So let's go to our server. And when you get the option prompt, you're going to want to make sure specifically for our project today, that we're using the PyTorch AI kit, which is going to be this PyTorch 1.4.0 AI kit. This is going to be what we're using. Since the AI model already is using the PyTorch frameworks, this is going to be the best one to choose with little to minimal code change necessary. So we're going to go ahead and select that one. Next, we're going to set up a server to configure the remote worker for the DevCloud. All right, so we've got an avatarify collab server set up here. And what we did is we imported the project into our oneAPI DevCloud after logging into our Jupyter notebook. So once you've logged in, you'll double click on the avatarify .ipynb file to open up this instructions. We're going to start the client and run a TCP tunnel. But first, before we do that, let's go ahead and just cover some of the install steps. So we're going to trigger each one of these steps by hitting Control-Enter for each one of these commands. Now, some of the steps I've already done. This first step here, you can see the avatarify folder was created. So we did the git clone, which created the folder. I created a change directory to the avatarify. Then the next thing we do is we get a git clone of the first order model. Now this will take some time to do. All right, so the last step we just skipped because it's going to take a few extra minutes just for sake of time. So the download data.sh was a big weights file. That's actually the model weights for the project. And the next steps here we're going to do is set up the groq tunnel. And in this groq tunnel, you will have the ability to set up a reverse SSH tunnel to be able to make a direct connection to your remote worker in the cloud. Next, we're going to change the directory to avatarify. So we added the squiggly line there just so that we reference the right path to the directory for our Jupyter notebook. And now that we've got that path secured, we can go and move forward with the rest of the steps in the Jupyter notebook file. So the next step here is going to set up our ports. So the input and output ports for communication to the groq tunnel. And just making sure that the work was completed. So I'm looking in the top right corner here to look for the activity. It looks like the activity for processes is complete. So we're going to go on to the next step to start the worker. So here we've just executed the steps. And when the command is executed, you will get a output print of lines on this next step. So we'll run this here, and then we should get some output. And this output we're going to use. Oh, it looks like we got a confirmation that the worker started. Now we're going to open up the groq tunnel. And like I mentioned before, I had to grab an auth token that you will need to sign up on the dashboard for groq. And I replaced that auth token with the one that I used for my account. And we just ensuring that everything has been running. Okay, so just making sure in the backend that the groq tunnel was open. And that I'm making sure I'm using the appropriate auth token and not the one that's default. Because if you use the one that's pre-built into this, it won't work. So you want to actually grab the one specifically from your dashboard in the groq tool. So I just replaced that with the one that I've got. Now we can go ahead and execute that command. We're going to set our region to the United States. If you're from another region, set the appropriate region to your country. And then we're going to type in the code for that region in this next box here. So we've got US down here. Next, we're going to run the next couple of commands and execute these in sequence. Control-Enter. Then we're going to get the tunnel addresses. So the tunnel is now confirmed open. Now, optionally, there's an AWS proxy you could set up. So if you don't want to use groq tunnel, you can use AWS T3 micro instances. It is free and can increase, I'm sorry, in this case, can lower your latency for the groq. So may actually improve the performance, but this is optional. What we will be doing for today's demonstration will be using the groq reverse SSH tunnel. But as you can see here, these are the steps for if you do the optional AWS proxy, you can follow those steps there. So now we are at the part where we can start the client. And so opening up a terminal window in Anaconda, opening the avatarify directory, changing the path, And then this next set of commands will give us the string that we can use in that command line to actually start running the application using the cloud. So here we're going to copy those cells. And then next what we're going to do is I'm going to open up another window. And from that window, we will paste the command in there and start the remote worker. The next steps assume you already installed avatarify on your local system by following the instructions from the open source community project linked in the reference page. All right, so the next step we're going to show is running the local inference on a 10th gen Core i7 thin and light notebook. And we're going to run the application just running off the local CPU, no remote workers set up yet. It's already configured, but we'll do that in just a second. So to compare the difference. So here we're going to start the camera, and you can see here I'm getting ready to frame myself into the shot. And here we go. Okay. So all this currently is running just local on the system. We have, let me pull up the frame rates here. So we're getting about 1 frame per second, which is about expected because this is an AI intense workload, which typically would require that high-end GPU to run most of it in real time. And so what we're going to show in a second is I'm going to start a call, but before we start the Zoom call, I'm going to revert back to the remote worker instead of running it locally. So let me close this. Stop the camera there, and then we're going to go ahead and run that same command we copied from the remote DevCloud. We're going to put that into our terminal and then run it here. And so this time, let me just reframe it again, kind of get the shot ready here. And okay, so now we're running it. This time it's in the cloud. We automatically already see a performance improvement. And as I move my face, the delay is much better. And our FPS is about 12 frames per second, so almost a 10-factor improvement when we went from the local inferencing to doing everything in the cloud. And so now at this point, on this Ice Lake 10th Gen notebook, we're going to go ahead and join a Zoom call. I've got one already prepared here, so I've got another system behind me that I just need to grab the passcode from. That's a 6B. Wonderful. So it's going to admit me into the room. I'll go ahead and get admitted in. And we will start video. Okay, so we just joined the Zoom call. We'll join with computer. Mute that so we don't get the echo. And then here I can make sure my face is lined up, make sure we're really calibrated so we can really have some fun. Make it look really nice and accurate. So I'm going to kind of line up my face, look straight at the camera, and press X. There we go. So now we're kind of actually pretty good in real time at this point. And again, this wouldn't have been possible without the assistance of a remote cloud host to kind of offload some of this work. But as you can see right now, we're kind of running the call. We can have some fun. I can change to a different avatar. Right now I'm using Einstein. He's a famous figure. But let's generate a randomly generated avatar. So this is a person that does not exist.com. Just pulls the randomly generated style GAN for a human to be generated. And here we have got a little girl here that we are, let's just go ahead and calibrate to that. There we go. So that's a little bit more accurate. And now we're on a Zoom call with a randomly generated avatar. I can go call my mom and she's gonna think, who is this person? So yeah, there's some of the fun things we could do there. I'm going to generate another person. So here's another random generated person. And ooh, let's see if I can match the smile. There we go. So yeah, that's pretty darn accurate actually, and that's almost nearly in real time. If we were to get about 30 frames per second, I would say that's the ideal. And of course, your internet connection is also going to be a factor. As when we do remote, offloading of this work, it's going to get intense on your network. So your network's stable network will be definitely necessary. But yeah, let's. I'm going to go ahead and close this out and exit this Zoom call, and I'm going to show another version of this same workflow, but we're going to do it again on a high-performance gaming notebook just to show a comparison, and we'll be right back. All right, so we are on a Windows platform now, and this time I'm showing a high-performance gaming notebook with a 10th gen Intel Core i9 10980 HK CPU. The system also has an NVIDIA RTX 2080 Super with Max-Q. And for our next step on the Windows system, we're going to show configuration of OBS Studio with the virtual cam plugin. For sake of time, I went ahead and already installed OBS Studio, and then I went and downloaded the virtual cam plugin and pre-installed that ahead of time as well. But make sure when you go through the steps and pick step 2 to only install one virtual camera. So that's all we need for our purposes today. So now we've installed that, we're going to open up OBS Studio and configure the next 2 steps here. Step 10 through 12 only need to be performed once for the initial configuration. After that, you just open OBS Studio and then join your Zoom, Skype, or Teams call from there. So let's get a remote worker going just to go ahead and start a window with the avatarify preview. So we've got the preview up. Let's go ahead and do a calibration. So we've got that going now. And so now we're running on the remote oneAPI DevCloud. I've got our frame rates here. So we're getting about 14 frames per second. It seems to be actually a little bit better, about on par with what we had on the Thin and Light Ice Lake notebook. And we're going to open up OBS Studio here and make sure that the camera that you're picking is the appropriate one. And actually, I don't know why. Oh, I think I know what's happened. So when the mouse comes into the frame here, make sure your mouse doesn't come in. And then let's go ahead and transform this to... Nope, don't want to stretch it. Just fit to screen. Maybe do that. There we go. That cleans it up a little bit. Okay, so let's calibrate this one more time. Ooh, did it again. Go ahead and do that. Okay, let's calibrate this one more time with Einstein. Okay, now let's join a Zoom call. So I've got a Zoom call waiting down here to join. We'll join with video. Gotta let myself get admitted into the call. So we will admit. And this time we're not going to join the audio. We're just going to go ahead and continue with just the video. And the video feed we're going to use here is our OBS camera. Make sure that that's selected and then start your video. And again, make sure for the best results on the deepfake avatar, make sure your face is in the frame of the red box. Make the same expression as the face of the avatar. So if I generate a random avatar, it takes a few seconds to load. So we've got one randomly generated here. This one's probably not the best example. I'm going to generate another one. It's best results when the face is facing just forward at the right angle. If it's coming off at an angle, it's hard to adjust. So I'm going to go ahead and generate another one. There we go. So that's kind of a good one. And then I'm going to kind of match my face and expression to his. So I'm going to kind of get back into frame here. Here we go. Okay, so now we are in the
Zoom call with our avatar. We can have some fun with some friends now at this point. And yeah, so we're running the remote worker. We're showing performance. I'm going to go close this out really quick, and we'll jump back into the Zoom call with our local. So this time we're going to run just windows.bat, which just pulls all the resources locally, all the AI inferencing is going to get done with a combination of the GPU. And then with OBS, there's a feature called Quick Sync Video that we will want to make sure is turned on. In fact, I might have to just adjust this really quick. Go back to OBS, make sure we've got the right camera. There we go. Let's pull this out of here. Kind of fix that. And then show our frame rates. So we're getting about 22 frames per second. We'll generate a random person. Generate another random person. Hey, there's a wide smile. Let's try to match that smile. All right, there we go. Now let's come back to our Zoom call. Start our video. And here we are on the Zoom call. We could start talking to our friends. They would be probably very confused with my voice with this face. But yeah, this is deepfakes running on the Intel gaming performance notebooks and also running on the Intel DevCloud for oneAPI projects. So thank you for checking this out, and we'll end this portion of the demo. One other thing I want to mention on the Intel-based platforms with OBS, if you're in Windows, there's another optimization that's pre-built into the application that takes advantage of a quick sync video feature set in the Intel CPUs, which is optimized for handling and offloading video between the CPU and the integrated graphics. By default, OBS will choose the NVENC, which is an NVIDIA encoder if you happen to have an NVIDIA-based GPU in your PC or notebook. And in this case, we're going to use QSV for Intel Quick Sync Video to squeeze a little bit extra performance out of the application, specifically OBS that's optimized for this. Now, avatarify is not quite optimized for quick sync video in that case because it's not necessarily an application that could take advantage of that feature set. However, avatarify can take advantage of some of the other feature sets, the deep learning and AI boost capabilities, the increased performance for AI-based applications and workload. But just make sure before you go into your Zoom call for your avatarify deepfake, just check your settings out and your output. And if you have quick sync video available, make sure you turn that on to take advantage of that optimization.
To learn more about how you can use oneAPI programming in your apps and join the dev community forums, check out the links provided. Thanks for checking this video out, and hope everybody enjoys their virtual SIGGRAPH 2020 experience and be safe. Thank you.